Hello everyone, welcome back to 7.3, day 3. We're almost done with the 7.3 content, and we've really been working on exponential expressions and simplifying exponential expressions. Let's do a little review on what we need. We need no negative and no zero exponents, so at the very end we can check that off. We need to make sure that all constants are simplified, and that really came into play yesterday when we saw constants like 9 and 12, and I wouldn't accept that, right? We would want to accept 3 over 4. Or I wouldn't accept 6 over 3. You would want it to be written as 2 or 2 over 1. And so we also need to make sure there's no duplicate variables. Now on our first day, that didn't really come into play. When we're multiplying everything out, we just combine all of those like terms. Whereas when we looked at day 2, we saw a lot of duplicates. We saw duplicates up above and below. So if I was to simplify all this, it'd be x to the 5th over x, and that would leave me with 2 x's, and I don't want 2 x's. So every time you see one constant on top and then the same one variable on top and one variable on the bottom, you're able to cross that out. And you can do that however many times you see duplicate variables. Just like this problem right here, there was a few duplicate variables. There was an x that crossed out with an x, so that was like one pair. An x that crossed out with an x, that was one pair. There was one pair of y's that crossed out. So we're going to look at a little bit of that today as well. But what we are adding is this. Let's add something to our essential question. Can I simplify exponential expressions with negative exponents? And that's our brand new thing today. And what do those negative exponents mean? And the first thing I want to clarify here is that an exponent will always write out that number however many times. So if it's x, or if it's 3 to the 4th, it's 4 3s. If it's x to the, or y to the 5th, it's still going to be 5 y's, but the negative is going to do something a little different. So let's see what that looks like. The best way for me to explain this is to just have an example. So we're going to dive right into an example here. If I write out 9x squared y all over 3x to the negative 2y. And so the only difference between this problem and a problem that I could have given you on our last day together, our day 2, is this negative exponent. So let's really look out and see what this looks like. Just like earlier, we see a constant, we write a constant. We see a variable, we write out that variable however many times. So x squared is x times x. A reminder, we're not going to put that little multiplication symbol in there. You could, but it's a waste of time. And y with a y. Nothing has changed so far because we haven't hit that negative exponent just yet. 3 becomes a 3. X to the negative 2. I'm going to have 2 x's, but the negative is what makes this little different. So the only thing different is that negative exponent, and a negative exponent moves the variable to the opposite side. Right, from the numerator to the denominator, or backwards, I should have closed that up there. So it goes from the numerator to the denominator, or the denominator to the numerator. So because it's in the denominator, it's going to move up above. Those 2 x's still exist. They're just going to come up here. I'm going to do a little bit of highlighting or a little bit of marking that moved up to the numerator. And that's what that negative exponent does. Everything else stays the same. Look at this y, still stays on the bottom. That is the only new concept for this day 3 here, is that negative exponent. Everything else stays the same. Let's finish it like how we normally would. Can I simplify these constants? Absolutely. That turns into 3 over 1. I have duplicate x's, but because they're all on top, they'll all move together. But I do see a y on top and a y on bottom, so I can cross those out. And I am left with, there's nothing duplicated or anything. I have the x's on top, but those can be duplicated. So I have a 3 left over, an x and x, an x and an x, that's x to the 4th. Well, and that's a 1, and that crossed out, so it's just over 1. So I would accept both of those answers, because you never have to have a denominator of 1, but it would be acceptable if you did. It's more mathematically correct to write it without, but both of those would be acceptable. So I'm going to have another video with a few examples. This video was just an example, or just included an example, I suppose, but it was really understanding what does that negative exponent mean.